Hello, my name is Herve Menager, and I work at the Institut Pasteur. I'm also leading the Elixir Europe Tools platform, together with Salvador Capella from the Barcelona Supercomputing Center and Björn Gröning from the University of Freiburg. I'd like to thank the BOSC Program Committee for giving me the opportunity to present this project, the Elixir Research Software Ecosystem. This project was initiated in the context of Elixir Europe. Elixir is a European life science infrastructure bringing together scientists from 23 countries and over 250 research institutes. It enables researchers to access and analyze life science data to improve the value and impact of life science research on public health, the environment, and the economy. Elixir comprises a number of platforms which coordinate activities in various technical areas. One of these platforms is the Tools platform, which helps researchers use or create software for the analysis of biological data. To carry out these missions, over the course of years, we have developed a number of resources. These systems help scientists with software-related tasks. They help them finding, evaluating, deploying, and running them. To find software, we propose two registries. You can think about them as yellow pages that reference and describe software. BioTools is a registry that describes and references software tools for data analysis in life science. Workflow Hub is another registry which is specialized in data analysis workflows. For the evaluation of software, scientists can find some help with OpenEbench. OpenEbench is a resource maintained by Elixir Spain that helps users evaluate software by integrating community benchmarks, but also monitoring metrics on the accessibility of software tools. Such indicators include, for instance, the accessibility of the repository or the documentation, or the existence of schema.org-based metadata for search engine discoverability. BioContainers is a project that provides bioinformatics software as containers, helping to deploy it in a portable and reproducible way. The generation of containers is highly automated and can be based either on Bioconda packages or custom Docker files. The containers are available in Docker and Singularity Aptainer formats. Beyond the local deployment of software, it can also be run on public infrastructure. One of these places is usegalaxy.eu. It's one of the major public Galaxy instances, providing users with the possibility to run more than 2,500 tools on a very large computing and storage infrastructure. All of these systems, which I just introduced, enable the fairness of software. That is to say, they make it more findable, accessible, interoperable, and reusable. However, the fuel that powers these systems is software metadata. Because these systems do not perform the same functions, the format and the contents of the metadata can vary a lot. I won't mention natural language documents, such as publications or documentation. But here you have slightly more structured metadata examples. On the left, you can see BioTools metadata format, which contains detailed scientific, technical, and administrative information about a given software. The top right example is the Bioconda metadata file, which informs about the version and technical requirements to build a specific package. And finally, the file on the bottom right comes from OpenEbench and stores the metrics about the accessibility of a given tool. As a result of the development of these systems, we end up with a large and ever-growing volume of metadata. Over time, the number of available software increases, and the metadata for each software are updated, if anything, at least because new versions appear. As an illustration of this, you can see here the growth of the number of entries in bio.tools, which is now above 29,000. The number of annotations for each tool, that is, the number of specific properties which are available, is now close to 500,000. So, in the long run, the cost associated with the maintenance or curation of these metadata can only grow, and this can have consequences on the sustainability of the system which rely on them. Additionally, there is a degree of overlap in the metadata stored about the same software in different systems, and therefore the collaboration between them can alleviate this curation cost. What we are building with the research software ecosystem is an open software metadata commons. The central idea is to improve the accessibility of software metadata by centralizing it in a repository. This repository federates all of the metadata from different resources. The goal here is not to provide yet another ultimate format for software metadata. We are format agnostic. Instead, we store metadata as much as possible in their native formats and try to facilitate cross-linking, validation, and curation. The ecosystem itself is designed with three types of actors in mind. For a software developer, it's easier to disseminate their products in multiple places and to maintain their description. For a software user, it's easier to find and access software with more metadata of better quality. And for a curator, the possibility to automate some tasks and share the curation workload. As I was mentioning earlier, this project is initiated by Elixir Europe, but it is meant to be as open as possible to any related project. Here, you have the examples of two external projects which have been part of our effort for a long time now. These are Debian Med, which is a community effort to package biomedical software for the Debian Linux distribution and derived distributions. BIII.eu is another registry of tools, workflows, and datasets that focuses on bioimage analysis. In more concrete terms, the ecosystem metadata are stored and available in a public Git repository. Each file represents the metadata about one tool available in one resource. The screenshot you can see here lists the metadata files for the FastQC tool, maintained in different systems, such as BioTools, Debian Med, OpenEbench, BioContainers, and so on and so forth. Additional files are also generated based on the imported metadata, such as a bioschemas JSON LD file, which can be embedded in the software website. The metadata contained in these repositories is imported automatically from the federated resources using continuous integration mechanisms. Metadata validation and conversion tasks are also extensively automated. With this architecture, we aim to have the most exhaustive possible number of metadata resources automatically imported in the repository, and extensively automated possibilities to cross-link and cross-validate the metadata between different resources. To illustrate briefly the benefits of this project, we can see here some recent improvements in the Galaxy Workbench, which use the ecosystem. One is the tool hierarchy on the left panel, which now includes sorting options that use the EDAM annotations of the corresponding entries in BioTools. The other is the direct link from the Galaxy tool page to the corresponding entries in BioTools and OpenEbench. Another illustration for the use of the ecosystem data is the Tool Finder and Workflow Finder systems maintained by the Australian Biocommons. These two web pages reference the software tools and workflows available on the Australian Biocommons infrastructure. Here, linked to bio.tools, biocontainers, and Workflow Hub allow users to directly navigate to these resources and retrieve additional information. The work on the ecosystem is ongoing. We are and will continue to expand its connectivity and features. For instance, we will synchronize instantly some resources, such as biotools, with the repository, so that a correction to the metadata happening on the repository is instantly propagated to biotools. We will also enable a synchronization between the ecosystem repository and individual software repositories to enable as much as possible its maintenance in the source repository alongside the code. Another future development is the export and synchronization with other software metadata formats beyond bioschemas, such as CodeMeta, to increase the interoperability of this work. In summary, the research software ecosystem is an open software metadata commons that federates metadata on a large set of bioinformatics software. This repository favors standards but does not advocate for one in particular. Over time, we hope that this resource will improve navigation and fairness of software, that it will enable metadata exchange, facilitate curation, and improve the sustainability of metadata-based resources. All the code and data for this project are available on GitHub under open licenses, and anyone is most welcome to reuse them or to join us in this project. This project was funded by Elixir, the research infrastructure for life science data. It is the result of years of collaboration between many people within and beyond Elixir, and I want to thank them all for their contributions and involvement. A special thank to my colleague from Elixir Spain, José María Fernández, for presenting a poster which describes this work. Thank you for your attention and feel free to contact or join us.